Okay, problem 1-5 is about calculation of Coriolis and Bussen's coefficient. So the velocity distribution in a rectangular channel of width 5 meter and depth of 2.6 meter was modeled as V is equal to lambda, which is a constant, y to the power of 1/2. So y is the water depth measured from the bed. So the question asks us to calculate the average velocity based on the given velocity profile, which we did that exercise in example 1-1. So please go and check that video. And in part B, calculate the correction coefficients of alpha and beta. So alpha is for energy and beta is for momentum equation. Okay, so here is the channel bed, water surface, and depth of y, and the velocity profile is described by a coefficient lambda y to the power of 1/2. Okay. So in the first step, we calculate the average velocity. We know that Q is equal to V times Y. Therefore, velocity is equal to Q divided by Y. So specific discharge is the integration from 0 to Y, V dy divided by Y. That gives you the average velocity. So the average velocity, V average. Now what we need to do is we just need to replace the expression of velocity based on depth, which in this case, then V average is equal to integration from 0 to Y, lambda y to the power of 1/2 divided by depth. So that becomes lambda is a constant, comes out. And then here we have 2/3 y to the power of 3/2, and then divide by y. So that gives us the expression for the average velocity, which is 2/3 lambda y to the power of 1/2. So we keep that expression and then use it for calculation of energy coefficient and momentum coefficient. So alpha is energy coefficient. And the expression of alpha is equal to integration from 0 to y, v to the power of 3 dy divided by v average times y. So now what I need to do is to replace the expression of velocity to the power of 3 and then replace the expression of the average velocity in here. So it's going to be integration of 0 to y, lambda y to the power of 1/2 to the power of 3 dy divided by, and that's v average to the power of 3. So 2/3 lambda y to the power of 1/2 to the power of 3 times y. Okay, so that gives me alpha equal to, so lambda is constant, it comes out of the integration, so it would be lambda to the power of 3, and then y to the power of 1/2 to the power of 3/2 gives me y to the power of 3/2 dy, integration from 0 to y. And then here I have 2/3 to the power of 3 times lambda to the power of 3 times, here I have y to the power of 3/2 times y. Okay, so I do the integration. So integration of y to the power of 3/2 becomes 2/5 lambda to the power of 3 y to the power of 5/2 divided by 2/3 to the power of 3 lambda to the power of 3 y to the power of 5/2. Okay, now lambda to the power of 3 and lambda to the power of 3 cancels out. Y to the power of 5/2, y to the power of 5/2 cancels out. So what is left is 2/5 divided by 2 to the power of 3 is 8, divided by 3 to the power of 3 is 27. So it becomes 2 times 27 divided by 5 times 8. So which gives me 1.35. So anytime you calculate energy coefficient or momentum coefficient, make sure that when you replace all the values, the depth and all the constants should cancel out. So if they don't cancel out, it means that you made a mistake somewhere in the integration process. Then we'll go with the Boussinesq coefficient or momentum coefficient. So beta is momentum coefficient. And the expression for momentum coefficient is beta is equal to, so integration of V square dy divided by V average square times y. So we do the same thing. So integration from 0 to y. So integration from 0 to y, lambda y to the power of 1/2 square dy divided by 2/3 to the power of 2 lambda 2 y to the power of 1/2 to the power of 2 times y. Okay, so lambda square is constant, so it comes out of integration. So I have lambda square, and then y to the power of 1/2, when it squared becomes y, and then I take the integration of y, so it becomes 1/2 y square divided by, and then I have lambda square times 2/3 to the power of 2. And then here I have y to the power of 1/2 to the power of 2 becomes y times y becomes y square. Okay, similarly, lambda square cancels out, y square cancels out. So what is left is 1/2 divided by 4/9. So it becomes 9/8 or 1.125. So then the momentum coefficient beta is 1.125 and energy coefficient is 1.35.